we have a sphere. A sphere is a locus of points in a space that are a fixed distance from a given point called the center of the sphere. Kind of like a three-dimensional circle. So every point on that sphere is the same distance from the center of the circle, or center of the sphere. A radius of a sphere connects the center of a sphere to any point. So we're used to seeing them straight out, but a radius could also go from here to there, or here to any of the spaces on that sphere. There. Radiuses are always congruent, right? Always congruent in a circle, always going to be congruent in a sphere. And then you have a hemisphere. You guys heard hemisphere before? Where do you hear hemisphere a lot? On maps and like on a globe. So you have the northern hemisphere and the southern hemisphere. So a hemisphere is just half of a sphere. And then the last little vocab word, a great circle divides a sphere into the two hemispheres. So what would be the great circle of the Earth? The equator, right? Divide it right in half. So we're starting out with volume of a sphere. So it is volume equals 4/3 pi r cubed. Kind of a funky way to how they get to that formula. It's on your blue sheet. Try to find it on your blue sheet. Find where the sphere box is. Yay. So how many pieces of information do we know or do we need to know? One. We just need to know the radius, right? So in this example, what's the radius of our sphere? 12, right? Goes from the center to the point, so it'd be 12 inches. So we're finding the volume and leaving it in terms of pi. So try this one on your own. So put it in our calculator. How do we do a fraction? Alpha y equals 4/3. And you gotta get out of your fraction and multiply that by 12, and then you're gonna do caret per cubed. So 2,304.
What do we have to write though? Pi. Don't forget that you have to attach the pi on there. A lot of times people forget that on terms of pi. They just write 2,304.
Right.
Yep.
Pi inches cubed. We're doing volume. Now we need to find the volume of a hemisphere. Hemisphere is what of a sphere? Half. So I'm going to take our volume formula. So it's 4/3 pi r cubed. I'm going to multiply it by 1/2. And before we even put anything in, we can simplify that, right? How do I multiply 1/2 times 4/3?
Straight across, right? So what is 1/2 times 4/3?
1 times 4 is?
4, 6, correct.
Which simplifies to 2/3.
So this isn't a formula on your sheet. Your blue sheet doesn't have hemisphere. So just remember, what's hemisphere? Yeah, so you could even find the whole volume and then just do what to it? Yeah, so or you can it's the same thing. So it's not on your blue sheet, just you have to be aware of that.
What's our radius in this case? 15.
Go ahead and throw it in. Let's do it to the nearest tenth. So if it's to the nearest tenth, what do you have to type in this time? Yeah, you need to put the pi in there. $7,068 point what? 6.
And what's our units? Meters cubed, we're in volume.
Some people say that as cubic meters, right? You guys understand that's the same thing? So sometimes, like, if it's typed out in a sentence, they might say cubic meters. That's the same thing as meters cubed. Yeah.
So now we have a composite figure to find the volume of. So basically, we start out with a cylinder, and then we're going to, like, carve out that hemisphere. So the volume of the solid is equal to the volume of what's the bigger shape? The cylinder. What's the volume of a cylinder formula? Look at your blue sheet. I was like, pi r squared times the height. Yeah. And we're going to subtract what's the volume, what are we taking away from that? A hemisphere. And let's do it the other way Mr. Starks talked about. Let's find the whole volume and then divide it by 2. So it's the whole volume of a sphere. What's that formula? 4/3 and then we'll divide by 2. Let's fill in what we know. We've got pi. What's the radius of the cylinder? 3, and what's that squared? 9. Oh, 3 squared. Because we only have half of that hemisphere.
It's not a full sphere, right?
Then our height of the cylinder. Minus, we got 4/3 pi. The radius of the sphere. Which 2/3 thing? You can. That's 3 cubed. What's 3 cubed? 3 times 3? 9. Times 3 again? 27. And then we divide by 2. Doesn't tell us it needs to be in terms of pi, so we can just type it all in our calculator. So starting off with the volume of a cylinder, so pi times 9 times 5 minus, we've got a lot of things being multiplied and divided, so let's put it in as a fraction. How do we do that? How do we do a fraction? Alpha y equals.
Math right up.
Math right up. And then we've got another fraction in there. So do the same thing. Do it again. Alpha y equals.
This is good practice because in Algebra 2, you'll have to put like fractions into fractions, and it gets a lot crazier. So kind of practicing doing this is good practice for next year.
So we've got 4/3 times pi times 27.
It's pretty cool that the calculator can do this now because like 3 years ago they couldn't.
You'll have to do that by hand.
They do a whole bunch of parentheses.
There's like a mess of parentheses in the calculator.
And then hit equal. Let's run it to the 100th place.
Oh, 100?
100? Why the 100? Why not?
For funsies.
84 point.
Oh.
84.82 times 82. And our unit is inches cubed on volume. Okay, so moving on to surface area of spheres. What's the difference between surface area and volume?
One's inside, one's outside.
One's inside, how much it takes to fill it. Surface area is on the outside. So if we're dipping the ball in water, how much would you apply? So the surface area of the sphere is 4 pi r squared. How many pieces of information do you need to know? 1. Okay. So let's find the surface area of the sphere with diameter of 76 centimeters. Leave your answer in terms of pi. So surface area is equal to 4 pi with our radius. Be careful. 38. Half of the diameter. And it's 38 squared. So to leave it in terms of pi, we're going to put the actual numbers in the calculator. So 4 times 38 squared. And then we can multiply it by pi in our answer. Centimeters, centimeters squared, centimeters cubed.
Surface area.
Surface area is squared.
Area is always two-dimensional.
Alright, this one isn't on your notes, but you've got a bunch of space over to the side so you can draw. I don't know how.
Oh, that was it?
Listen.
Hmm.
So we're finding the
That was it?
surface area of a hemisphere with radius 4. So our radius goes from the center out. So I have the surface area of the whole entire sphere. That is 4 pi r
Boy,
squared.
that looked like a straight dude.
Okay? That's the surface area of the whole sphere. So what do I need to do to get just the hemisphere? Divide it by 2. But when I divide it by 2, that only gets this part. This outside.
I like to think of it as like a watermelon. So the surface area is all the green, right? I love watermelon. And when you chop a watermelon in half, you're getting rid of half of the green, but what can you now see? All the watermelon on the inside, all the pink color. So what do we have to add on?
Watermelon is red.
It's
Watermelon is
red.
red.
I don't know what watermelon.
The circle. So surface area is a little bit harder than volume because if you chop a watermelon in half, the volume is just half of what it was, right? There's half as much watermelon to eat now. But surface area is talking about the surface. So if you take a watermelon, girls, and you chop it in half of the green is gone, but you now have the watermelon showing. So we need to add the pink watermelon circle.
How can we add the pink circle? What's our formula?
It's a red circle.
What's the formula for that circle? Pi r squared. So it's just a circle. Now we can simplify. We've got 4 pi radius divided by 2. So how many pi radiuses do we have? It's 4 divided by 2. 2. So now I have 2 pi r squared plus another pi r squared. We can condense that even more. How many
What's
pi r
2x
squared?
plus 1x?
3x.
3 x's, so 3 pi r squared. They're like terms, right? Kind of weird, but they're the exact same. They're both pi r squareds. So if you have 2 pi's and then you add 1 more pi, you have 3 pi's.
What's our radius? What's our radius? 4. It tells us that. Then I've got. So we're finding the volume of a sphere with a surface area of 324 pi. But we're looking for the volume. So what does volume equal? What's our formula? 4/3. But we don't know the radius. Right, we gotta reverse the surface area formula. The surface area is 4 pi r squared. And we know what this s is. What am I going to put in that place? 324 pi. How do I get r by itself? What should be my first step? Cancel out pi, and let's go ahead and divide out the 4 too. So divide 4 pi.
What happens when you divide pi by pi? They cancel. So really what you're just doing is 324 divided by 4, right? So that's what I would put in your, you don't need to put the pi's in your calculator because we know those cancel.
324 divided by 4. Nice and pretty. 81. Now what I need to do to get r by itself? Square root it. Square root of 81 is 9. Technically it's plus or minus 9, right? What's But can you have a radius of a -9? It's a distance